Guys, welcome back to my channel and I hope you are all doing great. Today we are going to see one more important problem from the Leetcode. The problem difficulty is easy. Problem number 283, move zeros. Let's see what this problem is all about. We are given an integer array nums and we need to move all zeros to the end of the array while maintaining the relative order of non-zero elements. Okay. Let's see this problem in a diagram for a better understanding. We are given an array like this: 1, 2, 7, 0, 0, 9, 3, 0, 8. Assume this is our input array nums, and our goal is we need to move this all zeros to the end of the array without changing the relative position of these non-zeros. Let's see how the output should look like. 1, 2, 7, 9, 3, 8, then all zeros. 1, 2, 3. This is how our output should look like. Okay. If we carefully observe, the number of elements in an array is going to be between 1 and 10 to the power of 4, and the value is going to be minus 2 to the power of 31 to 2 to the power of 31 minus 1. These are the constraints they given to us. Let's see in how many ways we can solve this problem. The first way could be we can take a new array. And we start iterating to the original array, and whenever we encounter a non-zero element, we can insert that. Let's see how it is. Assume this is our input array: 1, 2, 3, 0, 0, 7, 0, 9, 4, and 0. Assume this is our input array. So how we can solve this using this approach, taking the new array? Okay, we need to initialize this new array with the same size of this input array. In this array, how many elements we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, new array length is going to be 10. Okay, and we start iterating from first element. Okay, and this is how our new array will look like. And it is going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and first is 1, which is non-zero. Then I am going to insert here, and then 2, which is also non-zero. Then I am going to insert here, and 3, which is also non-zero. Then I am going to insert here, and 0, I am going to skip, and 0 again skip. Then 7, which is non-zero. Then I am going to insert 7 here. Then 0, skip. Then 9, which is non-zero, then inserted. Then 4, which is non-zero, then inserted. Then next 0, skip. If you see carefully, we inserted total 6 elements here, right? Total 6. So what is the default value of an int? The default value of an int is going to be 0. Right? So the moment you initialize this new array, okay, all 10 places is going to be filled with zeros only. Okay, and whenever we find a non-zero element, we are replacing the 0 with that non-zero element. Okay, in this case, so 6 elements will be inserted and 6 zeros will be represented here with the non-zeros, and remaining we no need to worry because the default values is going to be 0. Okay, this is how we can solve this problem. But what are the time and space complexities with this approach? The time complexity is going to be big of n because you are going to iterate only once, right? But space complexity is also going to be big of n because you are taking a new array and where we are going to store the n elements, right? Where n is the number of elements in the input. So this is a drawback with this approach. Space complexity is big of n. Okay, if we carefully observe the problem, what they are asking is note that you must do this in place without making a copy of the array. Okay, and we need to minimize the total number of operations done. Okay, in this case, can we do something such that we can avoid taking this new array? Yes, we can solve this problem with the big O of 1 space complexity. That is nothing but applying the in place algorithm. In place algo. Okay, in place algorithm is nothing but modifying the original input such that it can be output also. Okay, let's see how we can solve using in place algorithm. As I said, our input is going to be like this: 1 2 3 0 0 7 0 9 0 4. Assume this is our input. What I am going to do here is I am going to take a variable called index. Okay, initially this value is going to be 0, and whenever I start iterating from first of the element to the last, whenever I encountered a non-zero element, then I'm going to insert that value in the index position, and this index will keep on increment. Okay, let's see how it is going to be. Initially index is 0. Okay, and I have 1, so 1 is non-zero. Then I'm going to insert this one at the index position. So what is the index? 0. Then 1 will be in the same position. Then index will become 1 here. Then I am at the 2. 2 is non-zero. Then at index position 1, 2 is going to be inserted. Yes, 2 will remain same on the same page, same position. Okay. Then my index will become 2. Then my value is 3, which is non-zero. Then 3 is going to be in the second position, that is in the current position. Then we are going to leave the same. Then 0, which is 0. Okay, then we are going to skip. Okay, then 0, which is also 0, then we are going to skip. Then 7 is a non-zero. Okay, and I forget to mention, as soon as this inserted 3, okay, the index is going to be incremented, right? First 1 is inserted, value 1 is inserted, then we increase the index. Then 2 is inserted, then we increase the index, such that after 3 insert, then we need to increase the index. Every time when we do an insertion, then we need to increase the index. Okay, and 7, okay, 7 is non-zero. Then 7 will be inserted at the position of 3. What is 3 here? Here, right? So at this position 7 will come. Okay, then we are done with this, and index value is going to be 4. Then I will be here 0. Then I am not going to perform any operation. Then I will come here. Okay, 9, which is non-zero. Then 9 will be inserted at the position of 4. So this is that 9 will be inserted. Okay, and index value is going to be 5. Then I will be here 0. Then I am going to skip. Okay, then 4, which is also non-zero. Then 4 is going to be inserted at position 5. Okay, here 4 is going to be inserted, and my index is going to be 0. If you carefully observe, after this complete iteration, I got an array something like 1 2 3 7 9 4, and these remaining values will remain the same, 0 9 0 4. And if you carefully observe, the first part is already consist non-zero elements, right? Non-zero elements. And this second part needs to be zeros only, right? Because we covered all the non-zero elements in the first iteration only. Then how we can do? My index is now at 6, right? So what is the length of this array? 1 2 3 4 5 6 7 8 9 10, right? The length is 10. Okay, and I am at index position 6. Then what I am going to do is, from position 6 till position 10, I am going to insert simply zeros. Okay, then in that case I can tell my array is going to look like this: 7, 9, 4. Then from 6th position, 0, 1, 2, 3, 4, 5 is done. At 6th position I am going to insert 0. Okay, the condition will be like 6 less than or equal to 10. Every time we increment this. At 6th position 0 inserted, then it will become 7. At 7 less than or equals to 10. Yes. At 7th position this got inserted, then it will become 8. 8 less than or equal to 10. Yes. 0 is inserted, then it will become 9. Okay, 9 less than or equal to this one. Yes. And I forget to say this should not be equal to, this should be less than, because if there are total elements, that means the index varies from 0 to 9, right? In that case this should be less than 10. Okay, then this will become 10. 10 less than 10 is false, then we are going to stop. In this case you can see the final output is what we expected, right? But what are the time and space complexities with this? The time complexity is going to be big of n, right? The space complexity is going to be big of 1, because we are not taking any additional new array to process this request. Okay, we are modifying the existing array only. We are just taking one variable which is going to have a track of non-zeros, right? I hope you got the intuition behind this problem. Let's get back to the coding and let's see how we can solve. And here is I am. First I need a variable int index is equal 0. First I need to iterate through the nums of array, and I need to position the non-zeros in proper positions. Okay, for that, for int I equals 0, I less than nums dot length I plus plus. Okay, and what is the condition? If nums of I is not equal to 0, in this case only I need to insert, and I am writing here index plus plus, such that every time when we insert, the index value will get incremented. Okay, nums of index plus plus is equals to nums of I, what is the values there. Okay, and we are done with this. After completing this for loop, all my non-zeros can be at the start of the array, right? Now I am going to insert all zeros at the end of the array. For that, what we can do? For int I equals to index, okay, and I less than nums dot length and I plus plus. Okay, and here nums of index plus plus is equals to simply 0. That's all. In this approach we solve this problem in big O of 1 space complexity. That is nothing but we applied the in place algorithm. Let's run it. Great, we got a expected output. Let's submit it. Awesome, this got submitted. And I hope you learned a new topic today. Thanks for watching this video. I request you to please subscribe my channel and like and share the video.